Yes, good day, man. Good fans out there. I still remain Dr. D.I. June, your chemistry lecturer on social media. All this while, we have been dwelling on calculations on general gas equation. We have just seen one in our previous lecture. Want to see another one again. Um, Before I continue, let me give you this information. For those of you who are serious with these lectures, because this STP of 18, standard temperature and pressure, if you look at some of the problems of calculation, either the final temperature and the final pressure may not be given. You have to determine it yourself. Why? Because at STP, source values are constant. So as a student at STP, you know it that this value is this. That's what the examiner is wanting you to know. Just like the atomic masses of elements from hydrogen to calcium, you are expected to know them off by heart. Now look at this information before I continue. At STP, that is at standard temperature and pressure, if the unit of the pressure is in Newton per meter square, Newton per meter square, like this, it means that the P1, which is the initial pressure, will be 1.01 times 10 to the power 5 Newton meter square. And then the P2, I'm sorry, the T2 will be 27 degree Kelvin. I repeat, when it is at STP, observe the unit of the pressure. If it is in Newton per meter square like this, it means the final temperature will be 1.01 times 5, times 10 to the power 5. And then when the final temperature will be 273. But if the unit is millimeter mercury pressure, the pressure is millimeter mercury pressure like this. If in the problem that is see the new unit, it then means that your P1, which is the initial pressure, will be 760 mmHg, while the initial temperature will be 273 degree Kelvin. These are constants that you also know. So let's go. Now look at the question here. At STP, a certain mass of gas occupied 800 cubic centimeter. Find the temperature at which the gas occupied 940 cm3 and has a pressure of 675 millimeter mercury pressure. Now the previous one we solved, the unit was in Newton per meter square. So if we look at the final pressure, it was 1.01 something. Now this one, now the unit is now in millimeter mercury pressure. So from this problem now, your initial pressure, because of the STP, will be 760, which is a constant. Then your initial volume, as it is in the question here, is 800 cm cube. Then your initial temperature, because it is at STP, it will be now 273 degree Kelvin. If you convert it, it becomes 0 degrees Celsius. So the final pressure is given in the problem here, which is what? 675 millimeter mercury pressure. The final volume is also given 940 cm cube. Then the final temperature, the T2, is what you are asked to calculate for. Now let's go to the formula. As usual, P1 V1 over T1 equal to P2 V2 over T2. Hence, what I mean by hence here is that When you have cross multiplied and taken T2 out as the subject of the equation, it now means that P2 V2 T1 all over P1 T1. So substituting the values as it is in this equation here now, your P2 is 675, your V2 is 940, your T1 is what? 273. All over, your P1 is 760, and your T1 is what? It's coming. Is it T1 there? Mm, T2. This is correct. Your T2 will be this. Your V1 is now 800, which is here. If you now work it out mathematically, you arrive at 285 Kelvin. So your final temperature is 285 Kelvin. But you wouldn't leave it like this because here you worked with what? 27 Kelvin, which was 0 degrees Celsius. So here you are going to convert this to Celsius by subtracting 273 from it. If you do that, you'll have 12 degrees Celsius. This is your answer. So please like it, comment, share this video, follow me, and also please subscribe to my YouTube channel. See you again. Thank you.